Good morning, children. Listen, today, fifth question from first exercise. Prove that the line segment joining the midpoints of the two sides of a triangle is parallel to the third side, whose length is half of the length of the third side. Listen again. Here given keyword is a triangle. Prove that the line segment joining midpoints of two sides of a triangle is parallel to the third side, whose length is half of the length of the third side. Okay. First keyword is a triangle. Let us draw the triangle first. Listen. Triangle. Okay. Let ABC be a triangle. Children, listen. Let A, B, C be a triangle. Let O be the origin. Suppose. Let O be the origin. Origin may be anywhere. Okay. Now, the position vector of A with respect to origin O is small a vector. The position vector of B with respect to origin O is B vector. The position vector of C with respect to origin O is good, C vector. Okay. Next, listen. Next keyword is midpoints. So midpoints of the two sides of a triangle. Midpoints of the two sides. So for our convenience, let D and E. Let D and E be the midpoints of the sides AB and AC respectively. Let D and E be the midpoints. Let D and E be the midpoints of the two sides of a triangle ABC. So let D and E be the midpoints of the sides AB and AC respectively. Now join AE. Join AE. Next, here D is the midpoint. Listen, MP means midpoint. And similarly, E is the midpoint. E is midpoint. That is, MP means midpoint. Now, we know that midpoint formula. Midpoint means that divides 1:1. Okay, can you tell me the position vector of D with respect to origin O is anyone? Yes. A vector plus B vector by 2. The position vector of D with respect to origin O is OD vector is equal to A vector plus B vector by 2. So, OD vector is equal to A vector plus B vector by 2. Okay. Similarly, the position vector of E with respect to origin O is anyone? Yes. That is OE vector is equal to A vector plus C vector by 2. So, A vector, OE vector equal to A vector plus C vector by 2. A vector plus C vector by 2. Okay. Now, again come to the question. Prove that the line segment joining the midpoints of two sides of a triangle, is parallel to the third side and is half of the third side. So, it is enough to prove. Can you tell me what is enough to prove? Yes. It is enough to prove DE is parallel to BC. It is enough to prove DE is parallel to BC. Next, half of the length. We want to prove the line segment is half of the third side. So the second result is DE vector is equal to half into BC vector in vector notation. In magnitude form, it is enough to say DE is equal to half of, yes, BC, half of BC. So two results we have to prove. Again, listen to any person. Let ABC be, listen, step 1, let ABC be a triangle. Step 2, let O be the origin. Next, let D and E be the midpoints of the sides AB and AC respectively. Then the position vectors of A, B, C with respect to origin O are OA vector is equal to A vector, OB vector is equal to B vector, OC vector is equal to C vector. Then the position vector of D and E are OD vector is equal to A vector plus B vector by 2 and OE vector is equal to A vector plus E vector by 2. Then we want to prove DE vector is parallel to BC vector. Also DE vector is equal to half into BC vector. It is our aim to prove. First let us write the theory portion. Listen. Step 1. Let ABC be a triangle. Let ABC be a triangle. Okay. Let ABC be a triangle. Let O be the origin. Let O be the, yes, origin. Let O be the origin. Okay. Step 2 ready. Next step. Now, let D and E are the midpoints of the sides AB and AC respectively, which is the third point. Let D and E, D and E be the midpoints of the sides AB and AC respectively. AB and AC respectively. Okay, theory portion completed. Now, we know that the position vector of A with respect to origin O is, yes, A vector. That is, let OA vector is equal to A vector, OB vector is equal to, yes, B vector, OC vector is equal to, yes, C vector. Then, what is position vector of D? Yes, that is OD vector. OD vector is equal to, yes, A vector plus B vector by 2. A vector plus B vector by 2. Next, position vector of E with respect to origin O is, yes, OE vector. OE vector is equal to A vector plus C vector by 2. So, A vector plus C vector by 2. Okay. Now, to prove. Listen, to prove. What we have to prove? DE vector is parallel to BC vector. So, to prove result 1, DE vector is parallel to BC vector. Okay. Result 2 is DE is equal to half of BC. That is, DE is equal to DE vector is equal to half of BC vector. So these two results we have to prove. Okay, now listen. Now we want to prove DE vector is parallel to BC vector and DE vector is equal to half into half of BC vector. So first consider DE vector. First consider DE vector. Listen, now DE vector is equal to second minus first. Can you tell me what is second minus first? Yes, OE vector minus OD vector. So OE vector minus OD vector. Okay, which is equal to? Yes, OE vector is equal to A vector plus C vector by 2. OE vector is equal to A vector plus C vector by 2 minus of OD vector. What is OD vector? Yes, OD vector equal to A vector plus b vector by 2. So minus a vector plus b vector by 2. Okay. Now next step. Yourself. Good. Bring, say, divided by 2, divided by 2. So 1 by 2 is common. 1 by 2. 1 by 2 of. Next step. Yes, first bracket as it is. A vector plus c vector. Next. Yes. Minus going to multiply inside. Minus going to multiply inside. Minus into a vector. Minus a vector. Minus into b vector. Yes. Minus b vector. Complete the boom bracket. Now simplification. Yes. Minus a vector plus a vector cancel. What is remaining? Yes. C vector minus b vector. So which is equal to half into c vector minus b vector. Okay. Which is equal to half into what is c vector? Yes. C vector is equal to OC vector minus what is b vector? B vector is equal to OB vector. Okay. Now it is of the form. Yes. Second minus first. That is second minus first. Which means say C second B first. Which means a BC vector. That is which is equal to half into BC vector. Whose left hand side is DE vector. Listen. DE vector is equal to half into BC vector. And it is of the form DE vector is equal to lambda into BC vector, where 1 by 2 is some scalar. Therefore, DE vector and the BC vector are, yes, parallel. Therefore, DE vector is parallel to BC vector. So, we proved the first result. See, DE vector is equal to lambda into BC vector. Therefore, DE vector is parallel to BC vector. We proved first result. Next, we want to prove DE is half of the length of the third side. Yes. See, it is a vector notation. Now let us write in magnitude form. Therefore, DE is equal to half into BC. So these two results we proved. Hence proof. Children, listen. Sixth question. Prove that the line segments joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. Listen again. Prove that the line segments joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. Okay. Here there are two keywords. First keyword is quadrilateral. We want to prove parallelogram. So given quadrilateral, we have to prove parallelogram. Okay. Also the keyword, the line segments joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. Okay. Here main keyword is, yes, quadrilateral. First let us draw the quadrilateral. Quadrilateral given, we have to prove parallelogram in which the line segments joining the midpoints of the adjacent sides form a parallelogram. So that is important. First we draw a quadrilateral. So let ABCD be a quadrilateral. Listen, first quadrilateral. Listen, let A, B, C, D be a quadrilateral. Let A, B, C, D be a quadrilateral. Let O be the origin. Origin is anywhere. I told already, origin is anywhere. Let A, B, C, D be a quadrilateral. Let O be the origin. Then let D, E, F, J, any one letter. Otherwise, instead of A, B, C, D, let us change the name. Let P, Q, R, S. Let P, Q, R, S be the midpoints of the sides AB, BC, CD, DA respectively. So let D, E, listen, let D, E, on the instead of D, E, F, one can take PQRS for our convenience. PQRS. Listen. Let P, Q, R, S. Okay. Let P, Q, R, S. P, Q, R, S be the midpoints of the sides AB, BC, CD and DA respectively. That's all. Next, let the position vector of A with respect to origin O is? Yes, A vector. Good. Position vector of B with respect to origin O is? Yes, B vector. Position vector of C with respect to origin O is? Yes, C vector. The position vector of D with respect to origin O is? Yes, D vector. Okay. Here, what is P, Q, R, S? Anyone? Yes, midpoints. Now, the position vector of P with respect to origin O is? Yes, midpoint formula. So, OP vector is equal to? Yes, A vector plus B vector by 2. So, OP vector is equal to A vector plus B vector by 2. Okay. Next, the position vector of Q with respect to origin O is? Yes, OQ vector. OQ vector is equal to? Yes, B vector plus C vector by 2. So, OQ vector equal to B vector plus C vector by 2. B vector plus C vector by 2. Okay. Next, the position vector of R with respect to origin O is? Yes, that is OR vector is equal to C vector plus D vector by 2. C vector plus D vector by 2. Next, the position vector of S with respect to origin O is? Yes, OS vector is equal to A vector plus D vector by 2. So, A vector plus D vector by 2. It is midpoint formula where P, Q, R, S are the midpoints of the sides AB, BC, CD, DA respectively, where P is midpoint. Here MP denotes midpoint. Q is midpoint of BC, so midpoint. And R is midpoint. Midpoint of R is a midpoint of CD. Next, S is a midpoint of a midpoint of DA. Now join PQ, QR and SR and SP. So join PQ, QR, RS and SP. So PQRS, we want to prove PQRS is a parallelogram. Given that ABCD is a quadrilateral, we have to prove PQRS is a parallelogram. Okay, now let us write the theory portion. Listen. See, step 1. Step 1. Let ABCD is a quadrilateral. Let ABCD. Let ABCD be a quadrilateral. Okay. Given that ABCD is a quadrilateral. Okay, step 1. Next, let P, Q, R, S be the midpoints of the sides. Yes, AB, BC, CD, DA respectively. Step 2. Let P, Q, R, S be the midpoints. Be the midpoints. Be the midpoints of the sides. Be the midpoints of the sides. Yes, BC. Midpoints of the sides AB. Okay. Midpoints of the sides AB. That is, P is the midpoint of AB. Q is the midpoint of BC. R is the midpoint of CD. Next, S is the midpoint of DA. respectively. Okay, again listen. Let ABCD be a quadrilateral. Let P, Q, R, S be the midpoints of the sides AB, BC, CD, DA respectively. Let O be the origin. Let O be the origin. Okay. Let O be the origin. Now, the position vectors of the points A, B, C, D are, yes, OA vector equal to A vector, OB vector equal to B vector, OC vector equal to, yes, C vector, OD vector equal to D vector. First you write that. Listen, now OA vector is equal to, OA vector is equal to A vector, OB vector is equal to, yes, B vector, OC vector is equal to C vector, OD vector is equal to, yes, D vector. Now, the position vector of P, that is OP vector. Can you tell me OP vector is equal to? Yes, OP vector is equal to, from the diagram, OP vector equal to A vector plus B vector by 2. OP vector equal to A vector plus B vector by 2. Okay. Next, OQ vector. OQ vector is equal to B vector plus C vector by 2. OQ vector is equal to B vector plus C vector by 2. B vector plus C vector by 2. Okay. Next, OR vector. OR vector equal to C vector plus D vector by 2. OR vector. OR vector is equal to C vector plus D vector by 2. Next, the last one is, yes, OS vector. OS vector is equal to, what is OS vector? A vector. OS vector is equal to A vector plus D vector by 2. So OS vector is equal to A vector plus D vector by 2. A vector plus D vector by 2. Okay, initial preparation ready. Now, listen. Given that ABCD is a quadrilateral, we want to prove PQRS is a parallelogram. To prove parallelogram, it is enough to prove, yes, the opposite sides are parallel and equal. It is enough to prove opposite sides are parallel and equal. That is to prove, it is enough to prove PQ vector is equal to SR vector. Similarly, we can prove QR vector is equal to PS vector. So that is our aim. So first let us prove PQ vector is equal to SR vector. First we take PQ vector. Now listen, PQ vector is equal to PQ vector. Okay, PQ vector is equal to, anyone? Yes, second minus first. PQ vector is equal to, second minus first means, yes, OQ vector minus OP vector. Okay, which is equal to, what is OQ vector? Yes, OQ vector is equal to, listen here, OQ vector is equal to, here OQ vector equal to B vector plus C vector by 2. So OQ vector is equal to B vector plus C vector by 2 minus of OP vector. What is OP vector? A vector plus B vector by 2. So A vector plus B vector by 2. Okay, which is equal to, yes, by 2 is LCM. Otherwise, 1 by 2 is common. Any one way. Suppose by 2 is LCM divided by 2. Long divide. Okay. What is first one? Yes, LCM 2 and divided by 2 and 1 2 is 2. Therefore 1 multiply with the numerator. Okay. What is numerator? B vector plus C vector. Okay. Now by 2 LCM. 1 2 is 2. So same. 1 into numerator. Yes. 1 into numerator the same. Now any idea? Yes. This minus going to multiply inside. We get minus into A vector minus A vector. Minus into B vector minus B vector. Okay. Any cancellation? Please? Yes. Minus B vector plus B vector cancel. which is equal to, yes, C vector minus A vector by 2, whose left hand side is PQ vector, box it. So we want to prove PQ vector is equal to SR vector, in which PQ vector is equal to C vector minus A vector by 2. Now consider SR vector. Okay, now SR vector is equal to, now SR vector equal to, similarly SR vector, how to find SR vector? Yes, second minus first. Second minus first means OR vector minus OS vector. Okay, which is equal to OR vector. What is OR vector? Yes, OR vector equal to C vector plus D vector by 2. So OR vector equal to C vector plus D vector by 2 minus of OS vector. What is OS vector? Yes, OS vector is equal to A vector plus D vector by 2. So OS vector is equal to A vector plus D vector by 2. Okay, now long divide, LCM 2 divided by 2. Now numerator, yes, 1 2 is to 1 2 is to. Therefore 1 into numerator minus of 1 into numerator. Minus going to multiply inside. Now yourself, yes, start. Very good. C vector plus D vector, yes, minus going to multiply inside. Yes, minus into A vector, minus A vector, yes, minus into D vector, minus D vector. Any cancellation, please? Any cancellation? Yes, minus D vector and plus D vector cancel. Which is equal to remaining? Yes, C vector minus A vector by 2. C vector minus A vector by 2. Whose left hand side is SR vector. Box it. Listen, 7th question from first exercise. If A vector and B vector represent a side and a diagonal of a parallelogram, find the other sides and other diagonal is a question. Here, given keyword is parallelogram. And one side, one diagonal given. We want to find other sides and other diagonal. So it is our A. First the keyword is parallelogram. Let us draw a parallelogram. So listen, first draw the parallelogram. Listen, parallelogram. Let A, B, C, D be a parallelogram. Let A, B, C, D be a parallelogram. Next, here AB, BC, CD and DA are the sides of the parallelogram. In a parallelogram, opposite sides are parallel and equal. Okay. And the next keyword is a diagonal. Diagonal, that is diagonal of a parallelogram. So because of diagonal, join the diagonal. Here, AC, one diagonal. Can you tell me next? Yes. Next diagonal is BD. Is next diagonal, join BD. Okay. Now again, if A vector and B vector represent a side and a diagonal of a parallelogram, then find the other sides and other diagonal. Here, A vector is a side and B vector is the diagonal. So let AB vector is equal to A vector. Okay. Let AB vector is equal to A vector. One side over. Next, a diagonal is given. That is, let AC vector is equal to B vector. That's all. Given that one side AB vector is equal to A vector and one diagonal AC vector is equal to B vector given. And what we have to find? Yes, the other sides. BC vector, CD vector, DA vector are the remaining three sides we want to find. And next, yes, next we want to find the other diagonal BD vector. So it is our A. Okay. Now let AB vector is equal to A vector and AC vector is equal to B vector. Listen. Let ABCD be a parallelogram. Let ABCD be a parallelogram. Let ABCD be a parallelogram. Okay. In which let AB vector is equal to, yes, A vector. Let AC vector is equal to B vector. let AB vector is equal to A vector. Okay, next step, let AC vector is equal to B vector. And AC vector is equal to B vector. Okay, to find, can you tell me what we have to find? Yes, we have to find BC vector, CD vector, DA vector, and yes, BD vector. Okay, given is parallelogram. In a parallelogram, opposite sides are parallel and equal. So using that property, here CD vector, listen, CD vector, we want to find this first CD vector. CD vector is equal to, CD vector and AB vector are parallel but opposite in direction. Here CD vector is equal to minus AB vector because opposite in direction, equal in magnitude but opposite in direction. Therefore, now CD vector is equal to minus AB vector. Why CD vector is equal to minus AB vector? Yes, AB vector and CD vector are equal in magnitude but opposite in direction. Okay, now which is equal to minus as it is. Okay, what is AB vector? Yes, AB vector is equal to A vector. Therefore, AB vector is equal to A vector, which is CD vector. One side is ready. Listen, one side CD vector is equal to minus A vector. Listen, AB vector is equal to plus A vector. Therefore, CD vector is equal to minus A vector. Okay, A vector. But opposite in direction, therefore it is plus A vector and it is minus A vector. Okay, one side is ready. Next, now consider the triangle ABC. In triangle ABC. Okay, anyone? In triangle ABC. Any idea? Yes. AC vector is equal to straight root, A to C. AC vector is equal to, yes, AB vector plus BC vector. So in triangle ABC, AC vector is equal to AB vector plus BC vector. So AC vector is equal to AB vector plus BC vector. Okay, which is equal to, what is AC vector? Yes, already we taken AC vector is equal to B vector. Very good. AC vector is equal to B vector, which is equal to. Next, AB vector. Can you tell me what is AB vector? Yes, AB vector is equal to A vector. AB vector is equal to A vector. Okay. Next, plus BC vector. What is BC vector? Yes, we have to find a BC vector. We want to find. So, BC vector as it is. BC vector as it is. Okay, that means a BC vector question mark. We want to find. Next idea? Yes, we can reverse it. That is, A vector plus B vector is equal to B vector. A vector plus a BC vector. A vector plus a BC vector equal to B vector. Okay, next is simplification. Yes, this plus A vector goes to right, becomes negative. That is, BC vector is equal to B vector minus A vector. Okay, listen. Here BC vector is equal to B vector minus A vector. Therefore, BC vector equal to B vector minus A vector. Okay, we want to find three sides, remaining three sides and one diagonal, in which CD vector equal to minus A vector. One result. Next, BC vector is equal to B vector minus A vector is ready. Next we want to find the next side is DA vector. Next our aim to find DA vector. Okay, anyone? Very good. BC vector, listen, BC vector and DA vector are parallel and equal in magnitude, but yes, opposite in direction. BC vector upwards and DA vector downwards. So BC and DA are equal in magnitude but opposite in direction. Therefore, DA vector equal to, yes, DA vector equal to minus BC vector. Now DA vector is equal to, now dA vector. Listen, dA vector is equal to minus BC vector. Minus BC vector. Okay, which is equal to minus of, what is BC vector? Yes, BC vector is equal to B vector minus A vector. So BC vector is equal to B vector minus A vector. Okay, next simplification. Very good. Minus going to multiply inside. Okay, yourself. Good. Minus into minus plus A vector. Minus into B vector minus B vector. So minus into minus plus A vector minus into B vector minus B vector, which is dA vector. Box it. So where dA vector is equal to A vector minus B vector. dA vector is equal to A vector minus B vector is ready. Now one side is given A vector and the remaining three sides ready. That is BC vector equal to B vector minus A vector, CD vector equal to minus A vector, and dA vector is equal to A vector minus B vector. Remember, the keyword is parallelogram. In a parallelogram, the opposite sides are parallel and equal. And here, AB vector plus A vector. But CD vector equal to minus A vector because opposite in direction. Okay. Remember, BC vector equal to B vector minus A vector. But AD vector equal to A vector minus B vector. What is the difference? Very good. The difference is here minus A vector, here plus A vector. Here plus B vector, here minus B vector. Because opposite in direction. Okay. Next, my aim to find. Very good. The next diagonal BD vector. I want to find next one more diagonal BD vector. Okay. Any idea to find BD vector? Yes. To find BD vector, select the triangle. In triangle BCD. That's all. In triangle BCD. In triangle BCD. In triangle BCD, yourself by the triangle of addition of vectors. Yes. BD vector is equal to BC vector plus CD vector. That's all. So BD vector is equal to yourself. Yes. BC vector plus yes CD vector. Listen, diagram itself answer. BD vector is equal to BC vector plus a CD vector. Okay. Now which is equal to? What is BC vector? Yes. BC vector is equal to B vector minus A vector. So BC vector is equal to B vector minus A vector plus CD vector. Okay, what is CD vector? Yes. CD vector is equal to minus A vector. That means plus of minus A vector. Now next step, yourself, which is equal to? Yes, B vector minus A vector. Next step, yes, plus into minus, minus A vector. Okay, which is equal to? Simplification, very good. B vector minus 2A vector, because minus 1A vector minus 1A vector. So we get B vector minus 2A vector, which is equal to BD vector. Okay. So BD vector is equal to B vector minus 2A vector. BD vector is equal to B vector minus 2A vector. So now I want to write result. Listen, result. The other sides. Listen, result one. Results, the other sides. Okay, can you tell me the other sides? Yes, very good. That is BC vector is equal to other sides. BC vector is equal to, yes, B vector minus A vector. B vector minus A vector. Next side, very good. CD vector. CD vector is equal to minus A vector. Next side, very good. dA vector. dA vector is equal to, yes, A vector minus B vector. A vector minus B vector. Okay, next. The other diagonal. Okay, the other diagonal is BD vector is equal to, yes, by yourself, BD vector is equal to Yes, b vector minus 2a vector. B vector minus 2a vector. Children listen, theorem 3 is a theorem 3. The medians of a triangle are concurrent, which is a theorem, which is 5 mark question. The medians of a triangle. The medians of a triangle. The medians of a triangle are concurrent. Yes, this is what to prove. Children listen, which is important 5 mark question. The medians of a triangle are concurrent. Listen, what is the keyword? Yes, triangle is the keyword. Let us draw the triangle first. So, in triangle ABC, yes, in triangle ABC, let ABC be a triangle. Let O be the origin. Let ABC be a triangle. Let O be the origin. Now, the position vector of A with respect to origin O is, yes, A vector. The position vector of B with respect to origin O is, yes, B vector. The position vector of C with respect to origin O is C vector. Which means OA vector equal to A vector, OB vector is equal to B vector, OC vector is equal to C vector. Okay. Next, come to the next keyword, medians. Medians means, what is meant by median? Yes, median means the line joining the vertex and the midpoint of the opposite side is called medians. So, the line joining the vertex and the midpoint of the opposite side is called a median. Next, the line joining the vertex and the midpoint of the opposite side is called a median. Similarly, the line joining the vertex and the midpoint of the opposite side is called a median. Here there are 3 medians are there. First, let us select the midpoints. Let D, E, F are the midpoints of the sides BC, CA and AB respectively. Let D, E, F. Let D, E, F be the midpoints of the sides BC, CA and AB respectively. Where D is the midpoint, that is important. MP means midpoint. And E is the midpoint. F is the midpoint. Okay. Now here join AD. Here AD is the median. Similarly, BE, listen, similarly, BE and CF are the medians. So these 3 medians meet in the same point. Okay. Here let AD, BE, CF are the medians. Okay. Now, what is the position vector of D with respect to origin O is? Yes, very good. Because D is the midpoint. So D is the midpoint. Therefore, OD vector is equal to B vector plus C vector by 2. That is, OD vector is equal to B vector plus C vector by 2. So, B vector plus C vector by 2. Next, what is OE vector is equal to? Yes, OE vector is equal to A vector plus C vector by 2. OE vector is equal to A vector plus C vector by 2. Next, OF vector. OF vector is equal to, yes, A vector plus B vector by 2. OF vector is equal to A vector plus B vector by 2. Okay. So, initial theory portion is completed. Now, we know that medians meet in the ratio 2:1. We know that medians meet in the ratio 2:1. Which means, now listen the theory portion, let G1 be a point, which is G1, capital G1. Let G1 be a point on AD. Let G1 be a point on AD which divides internally in the ratio 2:1. So 2:1. Listen, where AG1 is equal to 2 and G1D is equal to 1. So medians meet in the ratio 2:1. Now let G1 divides the median AD internally in the ratio 2:1. Then by the section formula, 1 into OA vector. 1 into OA vector plus 2 into OD vector divided by 1 plus 2. then you are going to get the first equation, which is OG1 vector is equal to. Similarly, let a G2 be a point. Let a G2 be a point on B which divides internally in the ratio 2:1. So listen, it is 2:1. Therefore, by section formula, OG2 vector is equal to OG2 vector is equal to 1 into OB vector plus 2 into OE vector divided by 1 plus 2. And after simplification, we get second equation. Now similarly, let a G3 be a point on CF, dividing it internally in the ratio 2:1. Listen, which is 2:1. That means G3 is equal to 2 and G3F is equal to 1. Now by section formula, 1 into OC vector plus 2 into OF vector divided by 1 plus 2. And after simplifying, we get the third equation. And we are going to get the equations 1, 2, 3 are not different. They are same and one. So that is a result we are going to prove. Okay. Now we say theory portion first. Let ABC be a triangle. Step 1. Let ABC be a triangle. Let ABC be a triangle. Let ABC be a triangle. Next, let O be the origin. Let O be the origin. Let O be the origin. Okay. Next step. Let D, E, F be the midpoints of the sides BC, CA and AB respectively. Let D, E, F are the midpoints of the sides BC, CA and AB respectively. Okay, 3 steps completed. Next, now we want to talk about position vectors. Now listen clearly. OA vector is equal to A vector, OB vector is equal to B vector, OC vector is equal to C vector, OD vector equal to B vector plus C vector by 2, OE vector is equal to A vector plus C vector by 2, and OF vector is equal to A vector plus B vector by 2. So which is the next portion. Now listen, let OA vector is equal to A vector, OB vector is equal to B vector, OC vector is equal to C vector. Okay, next step. OD vector is equal to, yes, B vector plus C vector by 2. That is, OD vector is equal to B vector plus C vector by 2. Next step, OE vector. OE vector is equal to A vector plus C vector by 2. Next, OF vector. OF vector is equal to A vector plus B vector by 2. OF vector is equal to A vector plus B vector by 2. So the position vectors are ready. Now, listen. Now the theory portion is, listen. Now let G1 be a point. Let G1 be a point on AD, dividing it internally in the ratio 2:1. Okay, now listen. Let G1 be a point. Let G1 be a point. Let G1 be a point on AD, dividing it internally in the ratio. Internally in the ratio 2:1. Listen, this theory portion from the diagram only. Let G1 be a point on AD, dividing it internally in the ratio 2:1. Then by the section formula, OG1 vector is equal to 1 into OA vector plus 2 into OD vector divided by 1 plus 2. That's all, or 2 plus 1. Now listen, OG1 vector is equal to, that is position vector of G1 with respect to origin O is given by OG1 vector is equal to, from the diagram, 1 into OA vector. 1 into OA vector plus 2 into OD vector. 2 into OD vector divided by 1 plus 2 by section formula. Now, next step yourself. Yes, thank you. Listen, here 1 into OA vector, OA vector. What is OA vector? Yes, OA vector is equal to A vector. Therefore, A vector plus 2 into OD vector. What is OD vector? OD vector is equal to B vector plus C vector by 2. So, OD vector is equal to B vector plus C vector by 2. Extend, divide. 1 plus 2 equal to 3. Now, yourself, very good. Where 2 to cancel. So, your answer is, therefore, A vector plus B vector plus C vector by 3. So, long divide A vector plus B vector plus C vector divided by 3, which is OG1 vector. Let it be the first equation. Okay. Now, similarly, now let the G1 be a point. Now come to the diagram. Now, let the G2 be a point. Let the G2 be a point on BE, dividing it internally in the ratio 2:1. Then by the section formula, 1 into OB vector plus 2 into OE vector divided by 1 plus 2. So the next version is, let G2 be a point. Let G2 be a point. G2 be a point on BE. Okay. Let G2 be a point on BE, which is G2. Let G2 be a point on BE, dividing it internally in the ratio 2:1. So, dividing it internally in the ratio. Internally in the ratio 2:1. Then by the section formula, yourself, yes, then by the section formula, here OG2 vector is equal to 1 into OB vector plus 2 into OE vector divided by 1 plus 2. So that is OG2 vector is equal to 1 into OB vector plus 2 into OE vector divided by 1 plus 2. Okay, now next step, yourself. 1 into OB vector equal to, yes, OB vector. What is OB vector? OB vector equal to B vector. Okay, next, 2 into OE vector. What is OE vector? Yes, OE vector is equal to A vector plus C vector by 2. So, which is equal to, OB vector is equal to B vector plus 2 into OE vector is equal to A vector plus C vector by 2. So, A vector plus C vector by 2. Long divide, 1 plus 2 equal to 3. Now simplification, yes, 2 to cancel, which is equal to, good, A vector plus B vector plus C vector by 3. So which is A vector plus B vector plus C vector by 3. Let it be second equation, which is OG2 vector. Children listen. Now step 3. Step 3 is, let G3 be a point. Let G3 be a point on CF, dividing it internally in the ratio 2:1. Then by the section formula, OG3 vector is equal to 1 into OC vector plus 2 into OF vector divided by 1 plus 2. And we are going to get a third equation. Now listen, the equation, let G3 be a point. Let G3 be a point. Let G3 be a point on CF. Let G3 be a point on this. Let G3 be a point on CF, dividing it internally in the ratio 2:1. Dividing it internally in the ratio. Internally in the ratio, yes, internally in the ratio 2:2. Then by the section formula, anyone? Yes, very good. OG3 vector is equal to OG3 vector is equal to 1 into OC vector plus 2 into OF vector plus 2 into OF vector divided by 1 plus 2. Okay, which is equal to yourself. 1 into OC vector? Yes, OC vector. What is OC vector? Where OC vector is equal to C vector. Therefore, C vector plus 2 into OF vector. What is OF vector? OF vector equal to A vector plus B vector by 2. So OF vector is equal to A vector plus B vector by 2. Now fully divided by 1 plus 2. 1 plus 2 equal to 3. Now 2 to cancel. Okay, next step. Yes, next step, A vector plus B vector plus C vector divided by 3. So which is A vector plus B vector plus C vector divided by 3, which is third equation. Whose left hand side is OG3 vector, which is the third equation. Okay. Now, what can we say about equations 1, 2, 3? Very good. They are one and the same. Listen, from first equation, second equation and the third equation, it is clear that RHS are equal. A vector plus B vector plus C vector by 3. RHS are equal. Therefore, LHS are equal. So, here from 1, 2, 3. From 1, 2, 3, it is clear that the position vectors of the points G1, G2, see the position vectors of the points G1, G2, G3 are one and the same. And let the common point be G. So that is why let it be G. First initially let it G1 and here writing G1, G2, G3 are not different. They are one and the same. So that is the meaning. Now from 1, 2, 3, the position vectors of the 3 points G1, G2, G3 are one and the same. The position vectors of the 3 points from 1, 2, 3, the position vectors of the 3 points G1, G2, G3 are one and the same. The position vectors of the 3 points G1, G2, G3 are one and the same. Are one and the same. Okay? From 1, 2, 3, the position vectors of the 3 points G1, G2, G3 are one and the same. Hence, they are not different. 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 Listen, hence, they are not different. Okay? The position vectors of the 3 points G1, G2, G3 are one and the same, which means they are not different. So that is important. Let the common point be G. Let the common point. Let the common point be G. Okay. Therefore, the medians are concurrent and hence the point of concurrency is G. Therefore, the 3 medians are concurrent. Therefore, the 3 medians are concurrent. Therefore, the 3 medians are concurrent and the point of concurrence is G. And the point of concurrence. And the point of concurrence is G. And the point of concurrence is G. Listen, next theorem 8.4. A quadrilateral is a parallelogram. if and only if its diagonals bisect each other. Is a theorem. Here listen, if and only if is a keyword. If and only if. A quadrilateral is a parallelogram if and only if its diagonals bisect each other. Here if and only if means, first let us assume that a quadrilateral is a parallelogram. Then we want to prove its diagonals bisect each other. Conversely, assume that the diagonals bisect each other, then we want to prove quadrilateral is a parallelogram. That's all, which is the meaning. So here, if and only if means, if and only if before one statement and if and only if after one statement. Let us assume that the first statement is true, then we want to prove the second statement is also true. Conversely, let us assume that the second statement is true, then we want to prove the first statement is true. Which means, listen, the real meaning is, assume that quadrilateral ABCD is a parallelogram, then we want to prove its diagonals bisect each other. Conversely, assume that diagonals of a quadrilateral bisect each other, then we want to prove ABCD is a parallelogram. So it is our aim to prove. So let the first statement be true. We want to prove the second statement also true. Assume that the second statement is true, then we want to prove the first statement is also true, which is the meaning of if and only if. That's all. Okay. Now let us draw the quadrilateral. Let ABCD be a quadrilateral. Let ABCD be a quadrilateral. Let A, B, C, D. Let ABCD be a quadrilateral. Let O be the origin. The position vector of A with respect to origin O is? Yes, A vector. The position vector of B with respect to origin O is? B vector. The position vector of C with respect to origin O is? Yes, C vector. The position vector of D with respect to origin O is? D vector. Okay. And we know that here AC and BD are the diagonals. Now listen to the theory question. Let A, B, C, D are the vertices of the quadrilateral A, B, C, D with diagonals AC and BD. So which is the first line. Listen. Let A, B, C, D be the vertices of the quadrilateral ABCD. Let A, B, C, D be the vertices. Be the vertices of the quadrilateral ABCD with AC and BD are the diagonals. With AC and BD are the diagonals. Okay. Listen from the diagram. Let A, B, C, D be the vertices of the quadrilateral ABCD with the diagonals AC and BD. Let O be the origin. Second step. Let O be the origin. Let O be the origin. Okay, let O be the origin. Now, we know that the position vector of A, B, C, D are respectively OA vector equal to A vector, OB vector equal to B vector, OC vector equal to C vector, OD vector is equal to D vector. So, which is the next? Let OA vector is equal to A vector. Similarly, yes, OB vector is equal to B vector. Next step, OC vector is equal to C vector. OD vector is equal to, yes, D vector. So initial theory portion ready. Now there exist two parts. Let us assume that a quadrilateral ABCD is a parallelogram. Then we want to prove its diagonals bisect each other. Conversely, let the diagonals bisect each other. Then we want to prove quadrilateral ABCD is a parallelogram. So that is our aim. Now let us consider part 1, part 2. Now listen, suppose part 1. Part 1 is Assume that quadrilateral ABCD is a parallelogram. Assume that. Let us assume that. Let us assume that quadrilateral ABCD be a parallelogram. Let us assume that quadrilateral ABCD is a parallelogram. Yes. Let us assume that quadrilateral ABCD is a parallelogram. Then we want to prove its diagonals bisect each other. That is our aim to prove. Okay. We are assuming quadrilateral ABCD is a parallelogram. Okay. What are the properties of parallelogram? Yes, very good. In a parallelogram, the opposite sides are parallel and equal. That is, AB vector is equal to DC vector. That's all. So we are assuming it is a parallelogram. In a parallelogram, the opposite sides are parallel and equal, which means AB vector is equal to DC vector. Therefore, AB vector is equal to DC vector. Why? Because AB vector equal to DC vector? Yes. In a parallelogram, opposite sides are parallel and equal. Okay. Next step. What is AB vector? How to rewrite AB vector? Yes, very good. Second minus first. AB vector equal to OB vector minus OA vector. DC vector equal to, yes, OC vector minus OD vector. So AB vector is equal to OB vector minus OA vector is equal to DC vector equal to OC vector minus OD vector. OC vector minus OD vector. Okay, hereafter yourself. Okay, what is OB vector? Yes, B vector. B vector minus OA vector equal to A vector is equal to OC vector equal to C vector minus OD vector equal to D vector. Okay. Now we want to group. How to group means bring D vector to left side. Minus comes left side. Yes, plus. A vector goes to right. Becomes plus A vector. Very good. Now listen. B vector plus D vector. B vector plus D vector is equal to A vector goes to right. Becomes positive. That is A vector already plus a C vector. Okay. Now we want to prove diagonals bisect each other. We want to prove diagonals bisect each other. That means diagonals bisect each other. Bisect means what? Yes, midpoint. That means we want to prove midpoint of the diagonal BD is equal to midpoint of the diagonal AC. Okay, what is midpoint of the diagonal BD? Midpoint of the diagonal BD is equal to B vector plus D vector by 2. Okay, which is equal to midpoint of the diagonal AC equal to, yes, A vector plus C vector by 2. Here, B vector plus D vector is available and by 2 is missing. And similarly in RHS, A vector plus C vector is available. A vector plus C vector is available and divided by 2 is absent. So for our convenience, divided by 2 on both sides. Listen, divided by 2 on both sides. Okay, divided by 2 on both sides. Next step, very good. B vector plus D vector by 2 is equal to A vector plus C vector by 2. Okay, what is B vector plus D vector by 2? Yes, very good. That is B vector plus D vector by 2 is equal to midpoint of the diagonal BD. Next in RHS, A vector plus C vector by 2 equal to midpoint of the diagonal AC. So which means, therefore, B vector plus D vector by 2 means midpoint of the diagonal BD. Midpoint of the diagonal BD is equal to, okay, A vector plus C vector by 2 equal to, yes, midpoint of the diagonal AC. Midpoint of the diagonal. Midpoint of the diagonal AC. Okay. Midpoint of the diagonal BD equal to midpoint of the diagonal AC means, yes, the diagonals bisect each other. Therefore, the diagonals bisect each other. Therefore, the diagonals bisect each other. Yes, the diagonals bisect each other. Part 1 is completed. Okay. See, what is part 1? Part 1 is, assume that quadrilateral ABCD is a parallelogram, then we want to prove diagonals bisect each other. Now, conversely, part 2 is given by conversely. Part 2. Part 2 is conversely. Conversely. See, conversely, assume that diagonals bisect each other, then we want to prove ABCD is also a parallelogram. So that is our A. So conversely, assume that diagonals bisect each other. Assume that diagonals bisect each other. Okay. Assume that diagonals bisect each other. Now our aim to prove ABCD is a parallelogram. Okay. Here we are assuming diagonals bisect each other, which means diagonals bisect each other. That is, now I want to move in reverse, that's all. So part 2 is nothing but reverse of part 1. Now we are assuming diagonals bisect each other. Therefore, midpoint of the diagonal BD is equal to midpoint of the diagonal AC, and midpoint of the diagonal BD is equal to B vector plus D vector by 2 equal to midpoint of the diagonal AC equal to A vector plus C vector by 2. And now we want to prove AB vector equal to DC vector, in which this by 2 no need. So multiply by 2 on both sides, by 2 cancel. You are going to get B vector plus D vector is equal to A vector plus C vector. Then we want to group, that is B and A one side, C and D one side. And what is B vector? B vector equal to OB vector, A vector equal to OA vector, C vector equal to OC vector, D vector equal to OD vector, OB minus OA equal to, yes, AB vector, OC minus OD equal to DC vector, that's all. So part 2 is nothing but reverse of part 1, that is our aim. Now, assume that the diagonals bisect each other, therefore midpoint of the diagonal BD equal to midpoint of the diagonal AC. Therefore, midpoint of the diagonal BD equal to B vector plus D vector by 2 equal to midpoint of the diagonal AC equal to A vector plus C vector by 2. Now, this by 2 no need. How to eliminate? Yes, multiply by 2. Multiply by 2 on both sides, 2 to cancel. We get a before step. And B and A one side, C and D one side, before step. That is B vector equal to OB vector, OA vector equal to A vector equal to OA vector, C vector equal to OC vector, D vector equal to OD vector. Then OB minus OA is equal to AB vector, OC vector minus OD vector equal to DC vector. Therefore, here opposite sides are equal. AB vector equal to DC vector means what? AB vector equal to DC vector means opposite sides are equal. Therefore, ABCD is a parallelogram. Therefore, ABCD is a parallelogram. So that's the idea. That is, part 2 is nothing but reverse of part 1. Okay, now assume that the diagonals bisect each other. Next step, midpoint of the diagonal BD. Midpoint of the diagonal BD is equal to midpoint of the diagonal AC. Midpoint of the diagonal AC. Okay. See, first step, second step. Okay, what is the before step? That is, midpoint of the diagonal BD is equal to, from the diagram also, midpoint of the diagonal BD is equal to B vector plus D vector by 2. So, B vector plus D vector by 2, which is equal to midpoint of the diagonal AC equal to A vector plus C vector by 2. So, A vector plus C vector by 2. Now, I want to eliminate by 2. Okay, any idea? Yes, multiply by 2. Multiply by 2 on both sides. Multiply by 2 means divided by 2 cancel. Okay, your answer is B vector plus D vector is equal to A vector plus C vector. Okay, now next step. Yes, A vector and B vector one side. A vector comes left side. D vector goes to right side. Okay, which is B vector minus A vector, which is equal to already C vector minus D vector goes to right minus D vector. Okay, what is B vector? B vector is equal to OB vector minus. What is A vector? Yes, A vector is equal to OA vector is equal to, which is equal to C vector. C vector is equal to, yes, OC vector minus D vector. D vector is equal to OD vector. Okay. Now, B vector minus, see, OB vector minus OA vector is of the form? Very good. Second minus first. Second minus first means OB vector minus OA vector is equal to AB vector. If you are in doubt, AB vector equal to OB vector minus OA vector. That is second minus first. Okay. Similarly, which is equal to OC vector minus OD vector is equal to, yes, DC vector, because second minus first. Here first is D and the second is C. So which is DC vector. Okay. Here AB vector and the DC vector are equal. Where it is in the diagram is AB vector and the DC vector are equal. So where the opposite sides are equal? Yes, in a parallelogram. So AB vector is equal to DC vector. Therefore ABCD is a parallelogram. Therefore ABCD is a parallelogram. Therefore ABCD is a parallelogram. Hence proved.